want to be able to use differentiation to help us know where the stationary points or the turning points of a curve are, and also then to help us sketch a curve. Now, to sketch a curve, we just want a general idea of what it looks like and where the important points are. So we don't need a really accurate drawing. We don't need to plot lots and lots of points. But there are three things we want to do. We want to find where it crosses the y-axis, and that's where x is 0, and we've seen that in previous videos. We also want to find out, if possible, where it crosses the x-axis, in other words, when y is 0. And we want to find out the turning points. And at GCSE Further Maths, we'll either be given a quadratic or maybe a cubic. So I guess we should know what they roughly look like. So if we have a quadratic curve, it's either a positive quadratic, it's going to be a happy face. A negative quadratic then would be an unhappy face. A cubic curve we could expect to look something like a positive cubic, something like that. Or even if it's the graph of x cubed, it might look something like that. And a negative cubic, we would expect to go down from left to right and maybe have two turning points, a wee bit like that. Or again, minus x cubed looks something like that as well. So roughly we know what they look like, and we want to find the important points, like where does it cross the x-axis or y-axis? Where does it cross the x-axis? Where's the turning point? Where's the turning points? And if we can get all that information, and then we can plot a pretty good sketch. So here's one here. Sketch that curve. So first of all, let's do these 3 points. Find where it crosses the y-axis when x is 0. Okay, well if x is 0, y is equal to 0 minus 8. So that's minus 8. And so it crosses at 0 minus 8. When y is 0, we get that 0 equals x squared minus 2x minus 8. In other words, 0 is equal to x minus 4 upon x plus 2. And so x is equal to 4, or x is equal to minus 2. So we have 2 points. We have 4, 0, and we have minus 2, 0, because I know that the y coordinate is 0. And finally then we want to see, well, where is the turning point? And so for that we need dy by dx. So first of all, dy by dx, what's it equal to? Well, when we differentiate x squared, we get 2x. When we differentiate minus 2x, we get minus 2. So after that, we always say, to find our stationary points, at stationary points, dy by dx equals 0. So let's keep going with that then. So 2x minus 2 equals 0. So 2x equals 2, and x is equal to 1. So our stationary point is where x is 1. The y value of that, well, if x is 1, y is 1 squared minus 2 minus 8. So that's negative 9. And so we've got a stationary point at 1, negative 9. Now, I know that's going to be a minimum, but again, we want to prove it. So just d squared y by dx squared, second derivative. When we differentiate 2x minus 2, we just get 2. And that is a positive value, which implies a minimum turning point. It's a happy face. So all we have to do next is to do a little sketch. And I know that my graph goes down to negative 9. I need it to go across from minus 2 to 4 on the x-axis. Here's my x-axis. Here's my y-axis. I know 0 minus 8. So let's just put that in, is where it crosses the y-axis. I know it crosses at minus 2 and 4 on the x-axis. And you'll notice here, I haven't measured this out. I would have used a ruler if I had it for this computer package, but I don't. But, you know, that's roughly twice as much as that. I'm not too worried. What I also want then is my turning point, which is at 1 minus 9. So that's going to be roughly about there. So let's, again, put on the the coordinates on the axis. And then all I have to do is join these up. And again, I know it's a happy face, and let's go something like this. As smooth a curve as you can, and that's our sketch. Second example, something very similar. So where does it cross the y-axis when x equals 0? Well, we can see that y equals 0 plus 0 plus 5, so that y is 5. So that's the point 0, 5. Now when I go to find then when y equals 0, we get 0 equals x squared plus 4x plus 5. And I can't factorize that, so what I'm going to use is the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So my x values here are minus 4 plus or minus the square root of, well, b squared is 16, take away 4 times 5 times 1. And that's all over 2. But when we put that into our calculator, you'll find that this underneath the square root, 16 minus 20 is negative 4, and we can't take the square root of a negative number. So there's no solutions there. And you might think, oh my goodness, that means I've done this wrong. But actually all that's saying is this curve is not crossing the x-axis. In other words, it's going to be all above the x-axis. So don't panic just yet. Next thing, where are the turning points? So let's find dy by dx. And that's 2x plus 4. And at our stationary points, we know that dy by dx is 0. So 2x plus 4 equals 0. And so x is equal to minus 2. And if x is minus 2, y is equal to, well, minus 2 squared is 4. Minus 8 plus 5, well, y equals 1. So our stationary point is at minus 2, 1. And lastly then, what kind of stationary point is it? D squared y by dx squared. Well, when I, again, differentiate 2x plus 4 again, I differentiate dy by dx to get d squared y by dx squared. When we differentiate that, we get just 2. And that's a positive value, which is a happy case, so that implies a minimum stationary point at minus 2, 1. So again, our quick sketch, very quick, and again, make sure you use a ruler if you have access to it, rather than just this package. I know it crosses the y-axis at 0, 5, there we go. I know the minimum turning point is at minus 2, 1. There's minus 2. There. So that's 1. That's 5. And apart from that, I know it's a positive quadratic, so it's going to be a happy face. So it's going to look something like that on both sides. And there's our sketch. Again, you'll see, look, the curve doesn't cross the x-axis at all. And that's why we had no solutions here. Values that go with that. So our final example, I've said here, we're going to look at a cubic. A cubic will always have x as a factor, and that's at GCSE Further Maths. Will always have x as a factor. If you're looking at A-level maths, you could have to use the factor theorem, but that's not in GCSE Further, so we're not going to worry about it here. Again, let's find where it crosses the y-axis. So when x is 0, y is equal to 0 plus 0 minus 0. Y is also equal to 0, so 0, 0 is a point. Where it crosses the x-axis, when y equals 0, we get that 0 equals x cubed plus 4x squared minus 3x. And that looks quite tricky until you see that actually you can take x out as a factor. X squared plus 4x minus 3. Now again, I'm not sure how to factorize this. So I do know that either x is equal to 0 or this quadratic equals 0. So I'm going to use the quadratic formula again to solve this quadratic. So x is equal to minus b plus or minus the square root of b squared minus 4ac, again all over 2a. So for this quadratic here, that's minus 4 plus or minus the square root of, well, b squared is 16, take away 4 times minus 3 times 1. And that's all over 2a. So a is 1, so 2. And we're going to get two solutions for that, one with a positive answer and one with a negative answer. So the first solution that we get then is that x is 0.65, and the second then that x is minus 4.65. So the final thing that we need to do then is to find the turning points of this curve. So we're going to use dy by dx again. So dy by dx, when I differentiate here, is 3x squared plus 8x minus 3. And we know that to find the stationary points, at stationary points, dy by dx equals 0. So 3x squared plus 8x minus 3 equals 0. And this is one that we can factorize. We would use a split in the middle term method, but very quickly I'm just going to put that as 3x minus 1 and x plus 3 equals 0. And so again we get two solutions. We get x is equal to 1/3 or x is equal to minus 3. And again, when we put these values, x to the third, into the value of y, we get that y is, I think it's minus 14 over 27. And when we put it x is minus 3 in for that, we get that y equals 18. So we're nearly there. We just need to make sure that we know what type of stationary points they are, what type of turning points. So that's d squared y by dx squared. And so we're going to take our differential here, 3x squared plus 8x minus 3, and differentiate it again. So we're going to get 6x plus 8. And when x equals 1/3, d squared y by dx squared is 1/3 times 6 is 2 plus 8, that's 10. That's a positive value, happy face, which implies that's a minimum turning point. When we put x equals minus 3 into this, d squared y by dx squared, well, minus 3 times 6 is minus 18, plus 8 is negative 10. And so that's a negative value, unhappy face, that implies a maximum stationary point. So all we have to do now is draw our curve. Here's our x-axis and our y-axis. And I know that it has to go up to 18 here. So I'm going to put minus 3, 18 on. There's negative 3, 18. That's my maximum point. I know my minimum point was at 1/3 minus 14/27. So that's almost minus 0.52. So let's go 1/3 here. And this is minus 0.52. Just go in there. I know that it crosses at 0, 0 at 0.650 and minus 4.650. So let's put those in. There's 0, 0. There's 0.65. And then there's minus 4.65. And so it's a matter now of just joining up all these points. This is the maximum turning point. It's going to come down something like that. And then go up like that. And that's our cubic curve.